Thank you for joining me in a quick review of fractions. Let's look at divisibility rules to help with our work with fractions. Let's start with 2. We all know that a number is divisible by 2 if it ends in an even digit. The rule for 3 needs the sum of the digits to be divisible by 3. Since 3 divides evenly into the sum of the digits, 27, it will then divide evenly into 15,786. Since 4 divides evenly into 40, it then will divide evenly into 54,940. 5 will divide into any number that ends in 0 or 5. 6 prime factored is 2 times 3, so it makes sense that if both rules are satisfied, 6 will also divide into the number. So the number ends in an even digit, and 3 will divide evenly into the sum. Therefore, 6 will divide evenly into 12,852. Since 8 divides into 800, it will divide into 5,800. 9 needs to divide into the sum of the digits. Since 9 divides into 18, it will then divide into 5,823. The last divisibility rule I will state is the rule for 10, and this rule requires the number to end in 0. A prime number is a number whose divisors are only 1 and itself. The following is a partial list of prime numbers less than 100. For something to do, try Googling prime numbers less than 1,000. Let's write 80 as a product of primes. Needing to know the prime factorization of a number is necessary in finding the least common multiple or greatest common factor. Now you can start with any factorization of 80. How you start is not important. What is important is that in the end, you have a product of only prime numbers that will multiply to 80. So how about 2 and 40, where 2 is prime, but 40 isn't, and can be therefore broken down more. Continuing, where one factorization of 40 is 8 and 5. Continuing the process, writing 8 as 2 times 4, writing 4 now as 2 times 2. So here's the final prime factorization written in exponential form. Multiply to check. 2 to the 4th is 16, and 16 times 5 is 80. We have completely reduced when the numerator and denominator have no common factors. I am not going to start by prime factorizing these two numbers and then going on from there and canceling common factors. Instead, I will begin by dividing a common factor into both of the numbers. This will be a much faster process and will work as long as we can easily find a common factor. So what we see is 5 divides evenly into the numerator and the denominator, and then 3 divides into 21 and 102. Since 7 and 34 share no common factors, it is now in lowest terms. So here, common denominator, good. We combine the numerators, common factor of 2, and now it's in lowest terms. So with addition and subtraction, denominators must be the same. The least common multiple of 3, 6, and 9 is 18. So writing now equivalent fractions with 18 as a denominator, we are then ready to combine those numerators. Now, since there is a mix of addition and subtraction, we will need to move from left to right. And then before you walk away, again, make sure your answer is in lowest terms, and it is. Let's review the process of writing improper fractions as mixed numbers. Remember, your fraction line implies division. Start there by dividing for the whole number part of that mixed number. In finishing the process, we then write your remainder over divisor. Now remember, we don't need a common denominator with multiplication or division, only with addition and subtraction. but we do need to write mixed numbers as improper. So here we are writing mixed numbers improper. To do this, we multiply the whole part by the denominator and then add in that numerator. This always gets placed over that same denominator. Now recall, every division problem gets multiplied by the reciprocal of the second fraction. After the fractions are written as improper, you can see in the third step, the operation is now multiplication with the reciprocal of that second number. You are now ready to multiply, but before you do so, cross-cancel any common factors. After there are no common factors, then go ahead and multiply across. Now this has been an extremely quick review of fractions. It is meant to be a review. If you are learning it for the first time and needing more than the few examples I've provided, that may be a sign that you need to be in the previous course, a pre-algebra course. If you are uncertain which course you need to be in, then discuss this with your instructor.